Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the quadratic relations part of the course. It's question number 3 on a series of word problems that I've assigned. So, here's question number 3 from that worksheet. It says a cliff diver jumps into the sea. Her height in meters, t seconds after leaving the cliff, is given by this equation. So as always, let's make sure that we understand clearly what's happening in the equation before we even read the specifics of the question. So zooming in for a closer look at that equation, again, it's height in meters of a cliff diver jumping into the ocean or the sea or the water. So what do we know? Well, we know that the starting height of the diver is 35 meters, so we can assume that that's the height of the cliff. And we know, of course, that it's a negative parabola, meaning that it follows the laws of physics on planet Earth. It's a negative parabola. So we have the situation roughly like this. 35 meters above the ground. The cliff diver jumps, and I don't know if they go up a little bit or not, but something like this is going to be the motion of that diver jumping into the sea. So part of a parabola, roughly half of a parabola, and then this would be the water surface at height equals 0. Okay, so now that we have a sense as to what we're supposed to do, let's look at the first question. It says, how high is the cliff? Well, we've already answered that. We can tell looking here, and to be a little more specific if we want, we could say that the cliff height is the same thing as the diver's height at the start of her dive. So at the moment that the diver starts kind of falling, if you will, at the very instantaneous moment that she starts, she's at the same height as the cliff. So when t equals 0, h equals, and so if you look back at the equation, if you substitute a 0 for t, that makes this term 0, this term 0, you're left with h equals 35. So the starting height of the diver is the same thing as the cliff height, and we've already discussed that it's 35 meters. So let's go ahead and look at the next question. How long does it take her to hit the water? So again, here's the scenario, time and height, and something like this has happened. So how long does it take her to hit the water means I want to find time when height equals, well, again, she starts at 35 and she jumps to the water, and the water is considered to be a height of 0. So we're going to let the height equal 0, and we're going to find t, which is another way of saying, let's find the roots of this particular parabola, and one of them should represent the time it takes to hit the water. So letting t equal 0 gives me this equation. And how are we going to solve for t? Well, since it's a quadratic, let's use the quadratic formula. So t equals negative b. So b is 1, right? Because the coefficient there would be 1. Negative b plus or minus the square root of b squared minus 4 times a times c. Make sure I square root that. And all of this gets divided by 2a. So now it's time to pull out our calculator. Let's do some math. Okay, so negative 1 plus or minus the square root of something, and that'll be negative 9.8. So in the calculator, 1 squared minus bracket 4 times negative 4.9 times 35. So I get a number of 697. And now I'll break it into two separate answers. Oops. Sorry, my calculator's on my tablet. So t equals negative 1 plus whatever that square root is. Square root that. 26.4 divided by negative 9.8, or t equals negative 1 minus 26.4 divided by negative 9.8. So if we calculate both of them, we'll have the roots. So I get one root, negative 1 plus 26.4 divided by negative 9.8. So I get one root at negative 2.6 We don't usually like traveling backwards in time, so that's probably inadmissible. So let's see what our actual answer is going to be. How about 2.8? So again, thinking about the scenario, we have an imaginary answer over here somewhere in the non-real world side of negative 2.6, which is a root that doesn't exist in the real problem. So this root must be at 2.8. So therefore it takes 2.8 seconds to hit the water. Remember that water always has a height of 0, meaning it's at water level. Finally, how long does it take her to fall from 35 meters to 25 meters? So in this scenario, we know that she starts 35 meters above the ground. Somewhere around here, she's going to be at 35 meters. So we want to know how long does it take to go from here to here in her height. So I want to know what time is this? Because we know she starts at 35 meters. So how long does it take her to go from 35 meters to 25 meters? So in other words, let's find the time when the height is 25. So I'm going to let height be 25, sub it into the equation. And again, how do I solve anytime we're dealing with a quadratic? Well, we need to make it equal to 0. So I'm going to subtract 25 from both sides. That gives me this quadratic. And because it equals 0, I can solve using, again, the quadratic formula. So t equals negative 1 plus or minus 1 squared minus 4ac all divided by 2a. It's not hard to memorize that formula because if you've been doing enough work, you've used it enough that it's kind of automatically seared into your brain like song lyrics. So under that square root sign, let's see what the discriminant looks like. So negative 4.9, boop-a-doop-a-doop-doop, ding, ding, ding. Let's see. So under the square root sign, I get 197. And so now I'll split into two roots. So I get t equals negative 1 plus 14.0 over negative 9.8. And I get t equals negative 1 minus 14.0 over negative 9.8. And then again, we expect one of them to be an answer that doesn't make a lot of sense because of the negative or the invisible part of the parabola. So for example, here I get t equals negative 1.32. So that's inadmissible. Whereas on the other side, we get an answer of positive 1.53. So we'll say 1.5. So that means that to go from a height of 35 to a height of 25, so this section of the graph only took from 0 seconds to 1.5 seconds. So therefore, it took 1.5 seconds to fall to 25 meters. Now that was a fairly straightforward question, so don't forget, just playing with around here. If the question had not had 35 meters, let's say that this had said 30 meters to 25 meters, we would have to do this quadratic equation again, but having substituted 30 in here, subtracting it from both sides and using a slightly different equation, or sorry, using a slightly different quadratic in the quadratic formula, and then we would have gotten an answer, for example, from here to here and subtracted those. But this one happened to give us the easy beginning point and then only one point that we had to calculate. But I hope that that method makes sense. And that's the end of question 3. So I'll see you maybe at question 4. Bye.